Hi guys, welcome back. Today we're going to see the topic, the basics of algorithm. An algorithm is a step-by-step procedure to solve a problem. In normal language, the algorithm is defined as a sequence of statements which are used to perform a task. In computer science, an algorithm is a sequence of unambiguous instructions used for solving problem which can be implemented as a program on a computer. So, algorithms are used to convert our problem into a step-by-step statement, which any problem we can convert the problem as a step-by-step instruction or a step-by-step procedure to solve the problem. These statements can be converted into computer programming instructions, which form a program. This program is executed by a computer to produce a solution. There are some specifications for an algorithm. Every algorithm must satisfy these five conditions. First, input. Second, output. Third, definiteness. Fourth, finiteness. And the fifth, effectiveness. Input. Every algorithm must take zero or more input values from external source. Output. Every algorithm must produce an output as a result. Every statement or instruction in the algorithm must be clear and unambiguous. That means only one interpretation. There should not be any fuzzy statement. And number four, finiteness. For all different cases, the algorithm must produce the result with a finite number of steps. Effectiveness. Every instruction must be basic enough to carry out and it also must be feasible. So this is the general definition of algorithm. So let's start with a small example of an algorithm. Let us consider the following problem for finding a largest value in a given list of values. So our problem. So this is our task. So what is the problem here? We need to, the problem statement is the finding the largest number in a given list. What's the input? The list will be given. The list meaning the number of mm, in, many number of integers will be given. A list of positive integers, that is a list that contains one or more elements or one or more positive numbers. From these positive numbers, we need to find the largest of those numbers. So what is the output? Output is the largest number in the given list. Consider the given list of number as L. That is the input, and the larger number as max as the output. So algorithm step 1, define a variable max and initialize to 0. So this is the step 1 for any algorithm. We will be assigning a max because once the program finds the max, we need to have a variable to hold the max. So that's why we are assigning the variable max and it is initialized to 0. Step 2, compare first number, say the x in the list L with the max. If x is larger than max, set max to x. Repeat step 2 for all numbers in the list L. Display the value of max as a result. So here we are going to take the L number of, the list containing n number of items. So max is initialized to 0. Take the first number, compare to the max. If the first number is larger than max, then set max as the first number and go for the second number. Compare the second number with the max. If the second number is larger than the max, then replace or swap the max with the larger number, the second number. Likewise, keep going until the end of the list. Okay, so that is the repeat the step 2 for all the number of items in the list. And finally, once at the end of the list, you will be having the maximum number in the list as a result. So here we have the C coding. So it is implemented as a function or a method in to find max_cl. So in this function, we are passing the array or the list as a element to the function. We are initializing the max with 0 and I. For I, what is the purpose of having the I? Because this is for iteration, because we need to search all the number of the list, so we need to do the same work again and again. So we use here the for loop. For I equal to 0, I is less than the size of the list, I plus plus. For every item the list, the max will be compared with the particular item. If the particular item is larger than the max, then the item is replaced. I mean, the max will be updated with that larger item. And finally, once the list completes, once it comes to the end of the list, and finally return the max to the calling function find max. Okay, guys, this is how we do the algorithm. So in forthcoming video, we will be discussing the complexity, how to find the complexity of the algorithm in a different example. We will. Next topic is the recursive algorithm. Recursive algorithm plays a major and critical role in designing and solving a problem. In computer science, all algorithms are implemented with a programming language as a functions. We can view a function as something that is invoked or called by another function. Already, the viewers might have the knowledge of a computer language, computer program, and the functions and methods. Okay, so uh, it executes its code and then returns the control to the calling function. Here, a function can be called by itself, or it may call another function, which in turn call the same function inside. It is known as recursion. Recursion, in simple language, we can say that recursion is calling the same function again and again. A recursive function can be defined as a function which is called by itself, is known as direct recursive function. A recursive algorithm can also be defined as a function which calls a function, and that function calls its called function is known as indirect recursive function. So in general, we have two types of recursive function. One is a direct recursive function, another one is a indirect recursive function. A direct recursive function means a function called by itself again. A function is calling itself again and again. It's a direct recursive function. Indirect recursive function meaning a function calls another function. That function calls the calling function. It is like a triangle. A calls B and B calls A again, or A calls B, B calls C, and C calls A. So this is called as a indirect recursive function. Most of the computer science students think that a recursive is a technique useful for only a few special problems like a computing factorial, Ackermann's function, etc. This is unfortunate because a function implemented using assignment or if else or while or looping statement can also be implemented using recursive functions. These recursive functions This recursive function is very easier to understand when compared to its iterative counterparts. So, from this statement, we understood that a recursive function can be implemented on behalf of or implemented for if-else statement, while or any looping statement we can implement the recursive function. So recursive function is very easy when we are going to solve a complex problem like a say factorial or a 8 coins problem or a traveling salesman problem. We use a recursive function in the advanced algorithms. Okay guys, see you, bye bye, have a great day.